Hey, welcome back. Today we're going to talk about chain rule with multivariable calculus. But before we get into that, I want to kind of review differentials about what they're used for and how we can use them to approximate values. So let's say we're given a can. Now we're told the can has a height of 5 centimeters and a radius of 3 centimeters. And we want to calculate the following. The differential dV. So remember what this is telling us. We're looking for the differential dV. In other words, we're looking for the error in volume. Assuming the height has a maximum error of 0.2. So remember, this is the error in height. So we call that dH. And the radius has a max height of 0.3. So that is our dr, our change in radius. So we want to find the differential dV assuming for the height. So let's see here. My volume equation is pi r squared h. That's the volume for a can. And so let's see here. In order to calculate that error dV, remember this is the total derivative. What we've talked about in the past few lessons, that's our total derivative. So we can say that dV is, now we have to deal with the change with r, so let's deal with r first. And that is going to be the error, the derivative of velocity, or the partial velocity with respect to radius, dr, plus the derivative of velocity with respect to height, dH. And I can do this pretty much in my head, so therefore we can get dV would equal, okay, my velocity, my volume with respect to r becomes 2 pi RH dr plus my partial with respect to height becomes pi r squared dH. And I can just plug in our numbers. 2 pi, we're told the radius is 3, and our maximum error in the radius we told was 0.3. Whoops, I forgot my height. Let me get my height of the tube, sorry. The height is 5, and then dr is 0.3, plus pi. The radius again is 3, so that becomes 3 squared, which is 9, times the error in our height, 0.2. And if you type all of this in your calculator, let's go ahead and do that. We're going to type this in our calculator. I'm using TI Inspire. I love this calculator. 2 pi times 15 times 0.3 plus pi times 9 times 0.2. And I'm going to get this 33.929. And this is units, so it is cubic inches or cubic units, whatever that is. So that is the possible error. That is the error that is the maximum error in calculating the volume with this. If we would calculate volume, that's the most we could be off by. Alright, calculating the relative error. I know it's just the holiday season, so we're always dealing with relatives and their errors. Boom. Thank you very much. Remember, relative error is the error that we're going to be off divided by the total volume, the actual volume itself. So if we take that 33.929 divided by the actual volume, pi, the radius is 3, square that we get 9, and the height we know is 5. And let's see here. Let's go and type that in our calculator. I'm going to take that control divide, 33.929, and divide that by pi times 45, and I get 0.2399, so basically 0.24. So we get 0.24 or 24%. Ooh, so that's a pretty big error for the can. Like, we'd be off by quite a bit there. All right, the next question, this is where it gets a little more fun for us. It says, what is the max percent error for the height of the can? So to get the maximum percent error for the height of the can, well, that is for the height. That is just the error for the height is dH divided by the actual height of the can. So that's going to be 0.2 over 5, which is, let's see here, that is 2 over 50, which is, what's that, 1/25th or what, 4%? 0.04. And also for the radius, not in the radius, don't ever, whoops. For the radius, same idea, it is dr over r, the area for the radius divided by the radius itself, the actual radius, which is 0.3 over 3, and that's easy, that's just 10%, or 0.1, if you want to leave it like that. Alright, so any questions, leave them in my comments. So, pretty good so far. Alright, the next one is a little bit different. Now, we're going to see this on a test, and we're going to see this one again on a quiz. So, you're going to see this again. And it's basically showing a proof, okay? It says, show that the error in the volume of the cylinder is always twice the relative error of the radius plus the relative error of the height. So we're trying to find that the error in the volume, and it should be relative error, sorry about that, that dV over V is always twice the relative error of the radius, so that is 2 dr over r plus the relative error of the height, dh over h. Right. So this is what we're trying to prove. Okay, so let's prove this. So where do we start? Well, let's start with just the error in the volume. Well, the error in the volume, I already have that up here. That is this 2 pi r h dr plus pi r squared dh. And if I'm looking for that relative error in the volume, I just divide everything by v. So that's going to give me dV over V equals 2 pi r h dr. And what is the actual volume? Remember, that's pi r squared h plus pi r squared dh over, again, volume, which is pi r squared h. And I can cancel. Those cancel. And h cancels. And what I'm left with is 2 dr over r plus over here, pi r squared all cancel, dh over h. And we get that. Alright, hope you enjoyed this video. Please go to video number 2 where we're going to actually start talking about the chain rule. I will see you then. Bye-bye.